So, hello. Today we are going to solve the problem of the day, quicksort. And as it is being said that it is a divide and conquer algorithm in which we have to pick an element as pivot and partition the given array around the pivot. And the starting position of this array is low and the ending position is high. Now, if we look at the topic tags, we get to see divide and conquer and sorting. So, how are we going to do this quick sort is, first of all, what we'll be doing is, let me first clear this. We'll be picking a pivot element. And what we'll be doing is, suppose if we pick the very first element as our pivot, what we'll be doing is putting this 3 in its correct position, which means nothing but we'll be placing this 3 at its correct position such that, suppose if we have placed it at correct position, then all we have to do is to call the recursion to do the rest, right? So how are we going to put this 3 into its correct position? So in order to do that, we can make a partition function which will give us the correct indices, correct index at which this 3 should be put. So after putting this 3, our job is to sort these out. It's not our job actually. We can call the recursion to do this first part, which will call the recursion in this subarray and in this subarray as well, and it will do the rest. Right. So all we have to do is to pick this 3 the as the pivot element and put it to its correct place according to this array. So how are we going to do that? So in order to do that, we have been given a partition function. So what it will do is put our element, which is nothing but pivot, to the correct position, and the elements on its left should be less than the pivot element, and on its right, it should be greater than. So what is the intuition of this problem? So the intuition of the partition function is to first calculate, let us calculate the number of elements which are smaller than our pivot element. So how we can calculate is, so we will run a loop from the pivot element plus 1, which means suppose if we have taken the pivot element as the very first element of the array, so the very first index is L, right? So we'll run it from L plus 1 till high, high and right, high index. And what we'll be doing is to counting the number of elements which are smaller than our pivot element, right? It means that those smaller elements should be placed before our pivot element, right? Suppose as I wrote in the test case, we had 3, 1, 4, 5, and 2. This 3 is our pivot element. Let us take 3 as pivot element. And we iterate from here, and we get to see this 1 and this 2 are the elements which are smaller than our pivot element. And this 3 should be placed after these 2 elements. All right. So what we'll be doing is we'll be first calculating the pivot index. So how can we get the pivot index? We can get the pivot index by, suppose this is L, right? And this is H. So we can get the pivot index as L plus the number of elements which are less than 3, right? So L plus the count will give us the pivot index, and we will then swap whatever element which is placed here. So the number of elements which are less than 3 is 2. So our pivot index is, so again, let me write the test case in which we have indices like 0, 1, 2, 3, 4, and this element 1 and this element 2 is less than 3, right? So the pivot index would be pivot index, let me write it as pivot. So low, which is nothing but 0, plus the number of elements, which is nothing but 2, right? So 0 plus 2 is 2. So this 4 should be swapped with R3 in order to put this 3 at the correct position. So after swapping, we get to see 4, 1, 3, 5, 2. But still our job is not done. There are elements like 4, which is greater than 3 and still is on incorrect position. So we have to place this 4 on the right of the tree, right? So how do we do that? So what we'll do is we'll use an approach which is kind of similar to two pointer, in which we'll place our I index at here and J index at here. And what we'll be doing is we have the pivot index, right? We already have the pivot index. So while our I is less than the pivot index and the element at this index is less than our pivot element, right? If this is so, then we have no problem. The element is at its correct place. For example, if we had 3 on its left and 2 on the right, then according to our condition, if my element present at index I is less than element, the pivot element, right? If this is so, then we will do nothing but increment the I pointer. All right. But in this case, our 4 is greater than 3. So what do? We will check if there is an element present in the right which is smaller than 3. So we have 2 here, right? So what we'll do is we will swap these two elements. Swap ARR of I with ARR of J. ARR of J, right? And by doing that, we will get 2, 1, 3, 5, and 4. Now the element on the left is smaller than 3 and the element on the right is greater than. Now all we have to do is to wait for the recursion to do his job. We have handled the first test case. Oh, sorry, very first element, which is nothing but this 3. We have placed it we have placed it on its correct position, and we will just wait for the recursion to do the rest. All right. So now let me code this approach. Let us write the base case first. If our low is greater than has passed our index height, then we will do nothing but return. And now we'll calculate the index. It's called the partition function. In which we have passed our array, the low index and the high index. So the partition should be from low to what? To high, right? So for the very first element, for example, 3, the partition was from we we did the partition from start to end, right? And then what do? Then we call the bootstrap function again at its left and at its right. So from low to position -1 and from position +1 to high. All right. Now all you have to do is to find the partition pivot index. All right. So in order to do that, if uh, first of all we need a pivot element, right? So in pivot equal to, suppose the very first element is our pivot index. Now all you have to do is to count the number of elements greater than which are less than our pivot element and are on its right. So low +1 till high plus. So if array element I is less than our pivot. Then we increase the count. So let me declare the variable count. Now what do we do? The Let us declare the pivot index, and pivot index would be nothing but the L plus L is nothing but the my bad the position where the pivot element is present plus the number of elements which are less than pivot. Right? So we have the pivot index. Now all we have to do is to place our pivot element at pivot index, right? So how do we do that? Pivot I represent that pivot index will be replaced with our pivot element, and pivot element is nothing but low. So we have placed the element at the pivot, right? So this way has been placed. Now we have to handle the element at its right and element at its left. So how do we do that? So while our I is less than pivot index and our j, so let me declare the I and j. I equal to suppose L and j equals to I, less than I. So j is greater than pivot index. So now let us check if there is any element which is greater than 3, right? So if my I is if array element as I is less than my pivot element, so what do I do? I will simply increase the I, right? And similarly for j, so let us handle the edge case in which the elements are equal, the pivot element and the array element is equal. So let us put it on the left side. Pivot. In that case, we will decrement j. And now, if my I is less than pivot index and j is greater than pivot index, and the element is greater or smaller, right? So what do we do? We simply swap. Here are I, here are my bad, here are j, right? And in the end, we return pivot index, right? So compile and run and check if we have made any error. So let us submit. Okay, let us handle this case. Let us check if this works. All right, let us submit. This was the edge case. All right, thank you.